So hi everyone. I hope you can see me and hear me clearly. I'd like to welcome you to this session very much. My name is Dennis Kevogo and I've been the trainer for this particular team. I'm happy to see you guys here. I hope you're going to have a fruitful session as you present your thesis. Thank you, Alice. See clear.
Great. Yeah, right. Thank you, Dennis. Dennis has been our trainer for the last 4 months, and he's a very enabled trainer, and we are glad to have you here. We can have Mary.
Hi, good afternoon, all. It's a pleasure to have you around. And my name is Mary. I work at Predictive Analytics Lab. And I develop content. I'm the blog of the company. And I also oversee the operations of the company. Thank you for coming, and I'm sure it will be a nice event. Looking forward to have those who've not registered at Predictive Lab to just register and be able to become data scientists in 2021. Thank you, Alice.
We can have Ernest. You can do your quick introduction.
Okay, thank you, Alice. So my name is Ernest. I'm one of the trainers at Predictive Analytics. Yeah, I hope to enjoy this and welcome for the guys who are new here. So thank you.
Yeah, you're much welcome. And then we can have our coach, trainer, and our CEO. We're glad to have you here. Probably you can just introduce yourself, and then I will be giving your remarks later. Welcome, Tim.
Yeah. Thank you, Alice, and congratulations to our cohort 3 of our intermediate class. I'm happy to see your graduation today. I'd also like to welcome our guests and all the other participants who are joining us to witness this occasion. Because it's during COVID time, we would have been in a hotel somewhere, yeah, celebrating some champagne. But nevertheless, I hope the mood is still the same. This is an exciting moment for the graduates and also us as the faculty to be able to have walked through the journey together. Yeah, so thank you for joining us, and I look forward to a fantastic interacting session.
Yeah, thank you very much, Timothy, for that. So maybe I can just give a brief agenda of how it will be done, and then we can get started. So we basically have 4 projects. We have 4 groups with every group for 3 participants. So we shall be having around 15 minutes for every group to present. So it's just gonna be very quick. And I hope you've already organized yourself well. So that's how it's gonna be. So we shall be having 15 minutes of project presentation. We have a Q&A, an open discussion. Just feel free to ask any question regarding to the project. And then I shall have a discussion after every session. So that's how it's going to be. And let me now hand over to Dennis. As we get started with the first group. Yeah, Dennis, you're muted.
It's okay, it's okay. Just see. Thank you so much, Alice. Thank you all of you for joining us. I think we will proceed from here. So we intend to run this right from around 4:15 up to let's say 5:30 or 6. I hope we finish even earlier so that we can be able to see then what are some of the products that we have from our students. But before then, of course, with the permission of one of the candidates, I just want to present to you how our certificate looks like. And maybe that's not the agenda, but the agenda is to show you what the curriculum looks like. This is our data science level 2, or you can call it model 2. So it's a 4 months program, and across the 4 months, we covered module 1, that's the data science life cycle. More importantly, as we go into the edge of being a data leader and solving business problems, you need to understand what is the life cycle of data science, right? From the time you identify a business problem, you collect your data, up to the time to deploy your model and, of course, get predictive analytics from the same. And then secondly, we looked at now deep learning. We first covered recurrent neural networks, and then we proceeded with the web development using Django, and then which is one of the IDEs that are majorly used for Python language. We also looked at CNN on the other side of deep learning, majorly used, of course, as you may know, for video and image processing. Quite good, a very practical activity and very fruitful then. And then we also looked at machine learning APIs, a few examples, Microsoft Azure and the rest, and how you can deploy them when you want to then have a practical session, or rather have a practical field activity on your data. And then we looked at NLP, natural language processing. And of course, generally, what are some of the steps in pre-processing of your data? That was text data. How can you develop sentiment analysis and analyze text data? And then module 7, we looked at web scraping using scraping. And then we looked at CV, that is computer vision for face detection, quite a practical activity with a great team, of course, having taken us all through this. And then we looked at computer vision, that is object detection on the other side, with, of course, some of the most obvious CV libraries like OpenCV and the rest, like You Only Look Once and so many. And then we also have module 10, which we looked at credit scoring modeling. So largely, we look at our entire class, we see which industry do they fall in, and then we look, the majority, of course, then we look at a project that will be suitable for them. So if our next class, which starts in January, we'll have a majority in health, for example, we'll then do a what? Chronic disease risk score, which is similar to a credit risk score, only that this is in the finance world and the other one is in healthcare. And then we looked at introduction to big data engineering, and more specifically, one of the non-SQL and very common tools that are used for big data engineering, that is Hadoop. So that's how our course is packaged. So you can then tell that there is value for your money and time. So congratulations to the team, and one of them is Amundi Filida. I'd like to congratulate you. And of course, after the modules, the 12 modules, we then have the interview techniques, whereby we have a typical interview environment with panelists from the industry and of course from the local panelists here. And we would then to prepare you to see how it looks like when you are in a real interview in the field. And then we winded up now with the project phase, which is what we are doing. So you can see, you can look at it prospectively and retrospectively, in the sense that from module 1 to the last module, they all build onto the other up to the time now our students are doing their projects. So allow me just to then proceed and welcome our first group to proceed with their presentation. I think the group leader is Grace, who will proceed to do the introductions and take us through. You're most welcome, Grace.
Thank you, Dennis. My name is Grace, as Dennis mentioned. In group 1, we call ourselves Uzaji, with a sense of looking into the future and especially making things easier with regard to the retail industry. My group has Gekonyo and Tanvir, who we've been working on this project with. So our project revolves around sales forecasting, a time series analysis. And we were trying to come up with a model to forecast annual sales data. So in this presentation, our overview, we will look at the question we are trying to answer. We will also look at the data, the statistical models we used. We're going to have a comparison and finally recommendations. So to start off, like I mentioned earlier, we are trying to answer the question on sales forecasting. If we were to do a statistical model, how would we predict the next year's sales? So we are working with data from the retail industry, from an anonymous company, and it's a time series data. So our data has 613 days. It's based on days, and it has 2 columns, one column for the date and the next column for the value. We started by cleaning up the data, which was mainly aligning the date for months to be similar and filling in our missing values. We filled in our missing values by taking an average of the previous day sales and the day after sales to get missing values. Our missing values were not so many. Then with regard to processing, we decided to try 4 models. That's ARIMA, Holt-Winters, SARIMA, and Facebook Prophet. And then the whole idea is to do the predictions. So, okay, the presentation disappeared. Just give us a minute.
Yeah, sorry. Yeah. Can you see that?
Thank you. Thank you, Tanvir. Yeah, so the data exploration entailed as plotting how the original data set looks like, as well as identifying the stationarity, whether the data changes with time. And then after that, we moved to the next slide. We did the seasonal decomposition, which was to help us identify the trend, the seasonality, and the residues. So if you look at this, there's a trend that indicates there are certain times in the year that the sales go up. And with regard to the future, you can see the sales are going up. With regard to seasonality, there is a level of seasonality. And yeah, so to do, then after this, we did the correlation aspects. We ran the autocorrelation and the partial autocorrelation functions just to help us identify which model fits with regard to our data. So based on these two, the ACF and the PACF, they both taper towards 0, and which then drove us to run both autoregressive and moving average models. Yeah, I think after this, Tanvir can take over to the models.
Yeah, sure. Thanks, Grace. So we decided to take into account 3 various methodologies: Holt-Winters, ARIMA, SARIMA, and actually a 4th one for Facebook Prophet. As we were actually evaluating the data and going through the process of cleaning the data, we firstly ensured that our entire data set had no none values. We cleaned that, and the methodology of filling out the none values, rather than dropping it, we actually forward filled from the previous day's data to ensure continuity and no gaps. The first methodology that we actually used was Holt-Winters. Ideally, Holt-Winters is used in forecasting data which has prominent and obvious seasonality. Considering that there seemed to be some seasonality within the initial analysis, we began by running it through Holt-Winters. Here you can see is the plot of the data as forecasted by the Holt-Winters method. Here are the predictions and the results. So the first thing we did was plot the training and test data to see whether they fit together. And then from there, we actually generated a prediction and to identify how the prediction actually fit in with the data. And this was for 90 days. As you can see from the second graph, the green lines are actually the predictions, which are obviously a bit off, and came to the conclusion that Holt-Winters was definitely not the model that was going to be suited for this time series forecasting. Just to zoom in further, so we actually took just the snippet of the prediction and had the third graph where we could actually see how everything aligned together. And so besides just looking at the alignment, the visual alignment, we also generated the mean absolute error, the MSE, and so on. And at the end of the day, there is a coefficient, which is R² score, should come at least as close to 0, whereas the result for this was actually negative 0.48. And so once again, proving our thesis that Holt-Winters methodology for a non-seasonal data set is not the preferred method. And then from there, we went to one of the most popular methods, which is ARIMA, stands for Autoregressive Integrated Moving Averages. The initial bit we did was very similar to the previous steps, where we first initially plotted the data, defined our training model and test, and then finally went ahead and predicted it. You can see the alignment over here is a lot more better, just from a visual understanding. There is a methodology where we have to input the PDQ. So the P stands order of the autoregression, D is the order of integration and differencing, and Q is the order of the moving average. And so using AutoARIMA, the ideal recommended was 513, which was also confirmed by the previous slides in the ACF and the PACF. One thing in mind, consistently throughout the modeling, we used training 80% of the data of the original data set and used the last 20% as the test. Moving on next. So here you can see is, at least with the autoregression, we pretty much followed the same methodology of initially printing the original, the training and test data set, and then plotting the prediction on top of that. And then from the second plot, you can see now the forecasting in red. And so based on, so I've only zoomed into just January 2020, though our data began from January 2019. Towards the end of the year, there generally is a drop. And so based on that information and insight, the third graph that you see on the right shows the dip in the beginning of the year, and then eventually a pick. The hike in the middle of June, July represents pretty much the original hike in June, July, the original, as per the original data. Then we pulled out another methodology within the ARIMA was to actually explore moving averages, if moving averages would work better with this. So rather than using past values of the forecast variable in regression, a moving average model uses past forecast errors. And the moving average model is used for forecasting future values in the order of Q. And so from here, you can see that our predictions, specifically at the top, which is the simple moving average plot, accuracy was actually excellent, and we had a very low mean score on this, so proving that we once again had a very good forecast based on the simple moving average methodology. Then we decided to try one more time to see if we could actually merge seasonality into the methodology. And so we took up another model called SARIMA, which is just seasonal ARIMA, and plot the same again. As you can see, there seems to be some seasonality, which when eventually plotted, it was disproven. And the forecasting was actually non-conclusive. So we concluded that at least Holt-Winters and SARIMA are ideal for seasonal data. And that is when it's obvious data that has trends, say on a weekly or a monthly basis, spikes in sales, drops in sales, which are consistent, rather than in our situation where based on the business that we were analyzing, it was actually dependent on seasonality, specifically in agriculture and livestock. And that is Sarima. And now I would like to hand over the next piece to Gikonyo, who will explain the Facebook profit in time series. Thank you.
Hi, Tanvir. I think we are losing you. So kindly check your internet.
Sorry, can you hear me? Hello?
Yes,
Yes,
I
we
can
can.
hear you.
Yeah.
Just, I am handing over to Gikonyo. Gikonyo?
Okay, how are you, everyone? I was part of the Uzaji team that actually did this project in sales forecasting. And the last part, the last model that we used was the Facebook profit. The Facebook profit actually tries to use a plot that checks the trend and daily, also checks the holidays and also checks a process of where or how a person does their processes. An example of this can be seen on the second diagram, where you actually see that on during the weekends, during the week, the actual data, the actual processes are actually done on Monday to Friday, and on Saturday there's a dip. So with this, actually, you can actually see the process of how they actually do their work. Now, as per the data that when we inputted the data, you can actually see that the Facebook profit model will actually uploaded the data, and we actually see that it predicted an upward increment on the sales there on the sales. Now, with this, we actually saw that in 2021 there will be an increment of sales, putting in mind the trend, seasonality, and also the processes that are used within the organization. Next slide, please. Now, while comparing these models, we actually preferred we actually from our view, we saw that Sarima was provided a visual that was actually understandable, but from the median absolute error, we actually saw that Facebook profit actually had a lower error, and from this we actually recommended. From this data, we actually recommend that Facebook profit should be used as the model for sales forecasting using the data that we have. Now, the recommendations from us with the current data and the models that we used. We should actually have more. We should increase the amount of historical data in the next historical data. We should also include industry-related data, and also we should use machine language algorithms like the long short-term memory, so that we can actually have a more elaborate and more clean process of actual models to actually show or forecast in the future. Thank you.
Thank you so much. We now invite questions.
Any questions from the audience?
A good work, Tanvir. Mine is not a question. Tanvir, Gikonyo, and Grace, just a compliment, yeah, for the good work you've done.
Thank you.
And I would like to see now just to have some real industry applications. Did any of you have to bring in a challenge from their place of work and apply the model?
Yes. So one of us, actually, this is a work-related challenge that we are trying to solve.
Okay.
Yeah.
All right. Thanks. That's good. A good, very good plus. Keep it up.
Thank you, Timothy. Thank you, Dennis.
Yeah, so just one of the other things I wanted to add, firstly was, thank you, Timothy, for your compliment. And then secondly was, we did do some correlation in regards to data we had extracted from FAO as well to get a better understanding of why there were specific trends in, say, January and in June. And we were actually able to identify these trends through the planting season and the harvesting season, specifically crops. So we could see the correlation, and then hopefully the next steps is now to actually merge the correlation and see how it could fit together. But
all right.
Thank you.
Good.
Okay, that was really good, team. I would like to congratulate you and appreciate the work that you've done, the nights you've spent to ensure you have this possible, given that you're also working at your various places. Thank you so much. That was a wonderful presentation. Do we still have any question from the audience? So that if none, we will then proceed to the next group. Okay, so even as we proceed to the next group, allow me just to invite Tanvir. Tanvir, you just have 1 minute to give us a feedback on how the program was, and then we shall move to the next group.
Sure. Thank you, Dennis. The program was definitely very, very inspiring. I like the structure, especially on how the program was actually organized. You and the other lecturers as well had walked us through in very good details and explanations and support you provided us within and outside of class. And so I would recommend everyone who's out there, please, by all means, take up the course with predictive analytics. It's an amazing and awesome learning experience. Thank you.
Thank you so much. Thank you so much, Tanvir and team. That was really amazing. Allow me then to move to the next group, group number 2. I think that should be led by, is it Amondi or Dennis? So group number, sorry?
Our group that is next.
Okay, so kindly take stage.
Okay. I hope everyone can see my screen. Okay, good evening, everyone. So welcome to Group 2's presentation. And what we were handling was customer segmentation in Australia, and to be more specific on bicycles based on the different brands that were being sold. And my group members are, so my group members are Phoebe and Millicent. So the introduction, so bicycles arrived in Australia in 1860s, and the sport has been adopted by the citizens to the extent that they have formed touring and racing clubs. So this shows how the cycling culture in Australia is something that is very serious, and people cycle for different reasons. It can be for recreation, sport, or for transportation. And based on customer needs, the company, this is an anonymous company that we're dealing with, they must know which bicycles are preferred and by whom. So the objective is basically build a price prediction model, and then also understand the relationship between brands in terms of product line, product size, and product class, and also predict the probability of a particular brand being bought. And then the models we used for this particular exercise were decision trees, random forest, and gradient boosting trees. So the key features that we are looking at in this presentation is the main one is the bicycle brand, followed by the price. Then we have the standard cost. Then we have product line. Then we have product class, product size, and the different states within Australia. So on to data exploration. So our training set contained a total of 19,416 entries and 19 columns, which were interrelated. And based on the correlation matrix, you can see that this data is highly uncorrelated, and because it runs from negative 0.5 up to 0.3. So the correlation is weak in general. So so we look at the different bicycles by brand and state. So so the different bicycle brands that exist are we have Solex, we have Giant bicycles, we have Trek bicycles, we have it's called where A to B, and then OHM cycles, and then NOCO bicycles. And from the graph that we are presenting here, you will realize that Solex had the most preferred brands across different states, and then the NOCO bicycles had the least preferred brands, and then New South Wales, that is the state, has the highest count of bicycles compared to other states. So what this means is that a lot of concentration needs to be put under the New South Wales, and less concentration to be put on the other states compared to the New South Wales. And then study comparison of brand relation to product size, product line, and class. So product size, you see that medium product class, that is, so you realize that medium bicycles preferred across the different states, followed by the class bicycles, and we go to the product line. You will realize also that the standard bicycles are also generally preferred across the different states, followed by the road bicycles. In the least preferred bicycle brand is the mountain bike. And then when you're looking at the size, again, it is the medium size bicycles that are preferred. So generally, if company wants to optimize its production of bicycles, they will look at they will put more concentration on the and basically they will focus on the medium class bikes, and also focus on the outcome has to be medium sized, and it has to be a standard brand. That is the most preferred. So that is the most preferred bicycle in Australia. And then we look at the product line by state. So you will realize that in different states, it is the standard bicycle that is most preferred, followed by the road bicycles, and then again across different states, mountain bicycles are the least preferred. Just a minute. Okay, sorry about that distraction. And then again, if we're comparing the different aspects of the product across the different states, again, it's the medium-sized bicycles that are preferred. So the feature engineering that we used, we dropped unnecessary values when coming up with the models that you are using, where all the rows which had incomplete values were dropped. And we came to this decision after physically going through after physically going through different rows and we realized that if there's one that was incomplete, most of the other aspects were also not filled in. So we decided to drop it altogether. And then we also did data encoding on brand, product line, and product size, because it's mainly categorical data. And then we also did data normalization. And this was basically done so that you could increase the accuracy of the test model. And then techniques on handling imbalanced data. So one was the scenario where majority of data falls in one class. The second one was undersampling, where we discarded some samples from the majority class, and the major downfall to this particular technique was that we were going to lose a lot of data in the process. And also on oversampling, so the synthetic minority oversampling techniques was used, and this was basically to synthesize new samples and add to the majority class. And then, of course, we had to also use the weighted, we had to factor in the weighted loss function. And this one was basically used when we were looking at the mean squared error loss. And then the models used, the classifier models used were the decision trees and random forest. And then, so random undersampling metrics. So classifier scores. So for the random forest, we had a 98% accuracy prediction with a mean squared error of 5.15. And then for the decision trees, we had a 98% accuracy prediction with a mean squared of 1.27. And then to make our data like more accurate, so we decided to also look under the option of gradient boosting. And XGBoost had a 99% accuracy prediction with a mean scale of 0.328. And sklearn, well, it had a 90% accuracy level with a mean squared of 32,788. Yeah. And then in conclusion, so in relation to this data set, it was mostly categorical data. So we would like to recommend that more features such as activity, gender, and age be added to it so that a lot of other things can be looked at. And then more modeling techniques can be used to improve the model. And then better data analysis tools can be deployed to give better results in the future. And then we got our data from statista.com, and that's it.
Okay, so maybe Tim, you'll just come in first.
Yeah, so that's a good presentation to Philina and your team. So I'd like to congratulate you for taking your time to look at that, and especially anything that's consumer facing is always a very good problem because it really helps the non-technical departments appreciate the meaningfulness of using data in solving their day-to-day business. So yeah, I think that's a good job, well done. Yeah, so my observation is just how do you transfer this, assuming you're not talking about Australia? Is this something that's replicable in any region, territory, and also industries?
Amondi, that's your question.
Hear me?
Yeah, I can hear you now.
Okay, fine. It's because my audio seems to be having an issue. Okay, so this model can be replicated, especially, okay, let's take an example of Kenya. And if you're looking at something that, we can look at a sport that people like generally, and then we go back to the, for example, if it is, let's say, we can pick an example of a sport that people like. And let's just take an example of maybe football. And then we go back to the specifics, like which boots do people like to wear and why do they like to wear it, and based on which terrain, the people who are playing sports maybe in Western Kenya, what kind of features would they want. So using this model, it basically helps us understand what consumers want and the different preferences across different geographic regions. And this is important to any business, especially the marketing department or a production department, assuming that the boots were, for example, being produced in Kenya. Yeah.
All right. Yeah,
And then to add on, sorry. Just to add on it, this can be also applied to almost all industries, businesses, because for instance, if you're also selling like clothes and all that, someone in Mombasa, they prefer light clothes than heavy clothes. So this customer segmentation can really help you build better strategies, marketing strategies. Yeah.
Yeah, thank you. That's satisfactory. I'm happy with the feedback.
Okay, thank you. Thank you so much, team. Thank you, Amondi, Millicent, and the rest of your team. That was a good job. I invite questions from the audience. Any questions from the audience? Any questions from the audience? Okay, seems you don't have a question. So that was really a good job from our team, of course, led by Amondi and Millicent. And for John, like team has really insisted, then can you then replicate it to a more relatable use case? I was trying to build a health recommender system whereby could you recommend some certain sport activity for somebody who is, let's say, diabetic or pre-diabetic or any of the chronic diseases. So maybe you could engage on the same and see the way forward. That was really a good job. So I'll just invite Millicent just a minute to tell us how the program was, and then we shall move to the next group.
Okay. I'll just say it was a great experience learning with fellow students. The lecturers were great. We have learned so much. Definitely, we are going to add value to our workplaces. So it's a course I recommend for anyone interested in data science. So we learned a lot and we really do appreciate your efforts. We are grateful. Thank you.
Okay, no problem. You're most welcome. Thank you so much, group, and congratulations once more. Allow me to invite then Dennis Njuguna and team so that you can take stage. Dennis, you're welcome.
Yeah, I hope you're all well. My name is Dennis Njuguna with Group 4 actually, with myself, Nelly, Alice, and Justine, where we took on a project called crime prediction. And so we tried to think of how we'll try to predict crime on a certain area. Okay, and so what we did is we know that resources are very scarce, and so we try to predict crime so that we can help solve such, to help police maybe to minimize the number of scoutings that they do, so that since we know the locations. Okay, so maybe I can let Alice take you through the first section. Alice.
Yeah, so thank you very much, Dennis, for this invite. So yeah, we did this project, the 4 of us, but one is absent. Apologies. So I'm just gonna take you through the first part. So like Dennis said, it's a crime prediction project, and basically, simply put, Crime prediction itself, it's a practice of identifying probably the location, the dates, the hours, where we can be able to identify a specific crime happening, and then probably we can be able to find a solution for that. So we did our project, and our source data, we got it from a historical data set in Boston Police Department. So that's what we used. And then the plan, or rather the how we did it, the process itself, like any other data science project, we started with data cleaning. That's doing all the exploratory analysis for a data set. And then we also did data pre-processes. We did data visualization, and then we finalized with modeling. So the objective again, it's we first had to get to understand how the crime occurs in Boston before we start to do any kind of prediction. And how to identify that, it's by establishing probably the characteristic of the crime happening there. Is it personal, is it property, is there any shooting, or which kind of factors influencing that crime? And then also to develop the best model that be fit for that type of a data set. And then we started with data exploration, and that's where we ask ourselves some few questions, like probably what crime is more popular in Boston as we do exploration, what district has a higher crime rate, which year had more crimes committed in Boston, which day of the week, or rather the month, it's more prone to crime, what number of crimes were violent, which streets in Boston are safer than others, and probably the timeline when the timeline which is more prone to crime. So those are some of the questions that we asked ourselves. And then we then continue to do visualization to get more insights. For example, this one is one of our scatter plot, which is showing the longitude and latitude in different districts in Boston. So the legend, it's in form of different colors, which is scattered. Every color represents a certain district in Boston. That is based in this department there. We also did another visualization, which is comparing the timeline when it's more prone to crime. So the blue color, it's 0, which represents the daytime. We have the yellowish here, which is 1 representing night. So according to that, we can be able to see the bluish one, which is 0. So that means that it's during daytime that most of the crimes that usually occur there. And then we also did another exploratory analysis where we tried to visualize which crime is high. Like we tried to do the count of the crime which is more repeated, so we can be able to see there is the investigate person there, the highest count, so we can be able to tell that's the crime that probably can be able to occur severally and probably in prediction. And also we have the lowest in count here, so we can be able to tell that as well. And then we also did a heat map, which is basically showing the day of the week on our y-axis, and then on our x-axis we have the hour, so you can be able to, and also we have the legend here, which is like the guideline, it's with color, so you can be able to tell probably where the darker the color, the darker the color, you can be able to tell if it's on a Monday, and then we have the darkest color here, and then the timeline, so you can be able to tell the day and the hour where we can probably be predicting the crime to happen next. So that's using the unstack method and also reshaping the data frame there. And then also we also did another one, simple one, the count and also the year, probably to see for the last 5 years, which is from 2015 when we had the highest crime being committed there. And you can be able to tell it's 2017. Yeah, so basically that was it in a nutshell for the cleaning, processing, and visualization. And then probably can have Dennis taking us through the modeling part.
Yes. So right off, we then sliced our data. We decided to concentrate on the years between 2016 and 2018. Among the models we used were the logistic regression, decision tree classifier, KNN, and SVM classifier. So among the key features that we used were, we tried to consider the shooting column, which was a binary one, the date time, which included the stamp, the UCR part, which is the universal crime report part, which is given by the FBI, depending on the crime. The weather, we tried to enrich our data set by including the weather data, which included the temperature, the snow cover, which is measured in centimeters, the rainfall and the wind speed. And then we also considered the district. We also went ahead and added the unemployment rate by merging it to our data, and the crime type, of which we had 3 types of crimes, one of which included personal crimes, property crimes, and others. Later on, we decided to, during the data wrangling process, we tried to deal with null values, where we had, since we had a lot of data, some of our columns were null. So among them was like the latitude and the longitude. So we tried to imputate using the means. We also tried to drop some insignificant features. And then we also did some data encoding by creating dummies for some of our features, thus transforming our data. And finally, we tried to normalize our data using the standard scaler. Later on, since we had created our the slices of the training and the testing data, we passed them through our models as said earlier. We had 279,254 observations with 24 features. Using the logistic regression, we came about an accuracy of 90.5 with KNN. After trying the different values of K, we were able to come up with a 90.1% accuracy. The SVM and the decision tree classifier both came at 90, and both taking quite some time, which was interesting to run through. Yeah. And on to the conclusion and the recommendations. One thing that was tough to find was data, especially demographic data. So we would like to maybe try and run it with more demographic data, even though the data was for a small area. Maybe also trying to deploy it on the web, and maybe telling people to use our portal and add the different features and try to predict crime in their area. So we were impressed with the results of the classification models that we used, and maybe we would like to add other features so that you can see how well you can predict crime. Yes, I guess that's it. Maybe you could ask questions.
Okay, thank you so much for that. So maybe Tim.
That's a good presentation, Dennis and Alice. So you guys, they really put in a lot of effort. I can see in making sure that you have a very big problem that affects all of us. Yeah, so it's a very behavioral challenge, and I noticed a lot of your data. Yeah, what was the source of the data you are using?
Well, we use, okay.
Hey, Nelly.
Hi,
Yes.
I thought I could answer. We use the Boston crime data.
Okay. Yes, sorry, yes, I had that being mentioned. So you also need to be cautious of the data protection and the sensitivity of the data that you use for analysis. So mostly the data, especially in areas around healthcare and behavioral sciences like crime, yeah, has got some little bit of repercussions. So I'm just trying to prepare you for the real application world in case you may want to pursue this further, is to ensure that you have got the right clearance from the right sources of the data, right? Before you do any analysis and data processing. Yeah, but I'm familiar with the data sets. It's available on Kaggle, right?
Yes, it is.
Yeah. All right. Yeah. So are you what next for you with this project?
Well, as I had said, maybe we'd like to add more features, demographic factors, and try to look at some of those features, whether how much influence do they have in predicting crime. Yeah, that's it. And maybe try to deploy it for Kenya, a portal where the Kenya police can just add probably the location of a crime and the name of the crime, and then we can try to predict crime. Yeah.
Yeah. So just to prepare you now for, especially if you're pursuing this further, there are other newer types of data sets that we do use and are using the neural networks kind of analysis. For example, things like gait recognition, image and facial detection are now being used in detecting crime from a perceived risk. So I just wanted to prepare you for that and see how you can be able to start shifting from historical data to more intuitive data that comes. Yeah? But this is a good start for this level.
Thank you very much, Tim.
All right, good job, and yeah, all the best.
Okay, that was really good job, Dennis, Alice, Nelly, and of course, Justine. I really like the kind of products you are giving us right now. And I think, like we've said and still insist, can we then replicate this to the real life projects? It's quite good that also one of our projects was quite relatable and data was just from the industry that are already in and practicing. I think that's the kind of real life use cases we want to stage from predictive analytics. So at this juncture, I'd like to welcome questions from the audience. Any questions from the audience? Do you have any concerns in terms of data privacy? Do you have a question on that line? Would you want to know what are some of the challenges they encountered while developing this model? Okay. Any questions?
Maybe they could tell us the challenges which they faced while in the models. Yeah.
Okay. Okay. So who will take that?
Sorry, can you come up again?
What are some of the challenges that you encountered as you were building a model?
Well, as I said, was coming up with the right parameters. For example, for the SVM and the KNN, coming up with the best score of K, the number of clusters that we needed. That was one. Yeah, I guess that is one of them I would mention.
Okay, fine. Did you expect that maybe logistic regression would give you a higher accuracy than support vector machines?
Well, actually, I wasn't expecting any kind of thing. I wanted just to see how much they will predict our crime, and surprisingly, logistic regression came first.
Okay, because that's one of the interesting observations I was able to make, because generally, even from past experience, SVM tends to be a bit having a higher accuracy compared to logistic regression, but it entirely also depends with your procedure and the kind of data you are working with or working on. That was really good. Maybe we do not have a question from the audience. Okay, another question.
Was there a challenge when on which tool to use for the project, or you already knew what to do, what to use for just before you started the project? Was there a challenge on what tool to use?
Okay, maybe let me check that one. Right from the training we had in this level, we're able to use, we have the kind of language that you're going to use, which is Python, and then we have the libraries that you're going to use. And so since we had our data set as an Excel sheet, we knew that we were going to use pandas to wrangle up our data. And then we have the libraries for doing the machine learning algorithms. So we decided to use scikit-learning. And so during the training, we used, we were taught these things, and we were ready for the project.
Okay. Okay, good stuff. Thank you so much for that. So at this juncture, allow me to invite Nelly. We have a question in the chats before I invite Nelly to give us a feedback on how the program was. Just a quick question. I wanted to share your thoughts on how these models would work for the engineering firm dealing with mainly business to business or business to, yeah, I hope that was right. I mean, B2B, is it? So maybe Dennis, you could respond to that, or Nelly. Dennis or Nelly, either of you.
Wow, okay, that's an interesting one.
Maybe you
So,
could just comment on how relatable it can be to engineering, or how applicable. If I think that is B2B, business to business, I hope so. To whoever asked the question.
Well, maybe just to answer from a general point of view, since I am not well versed with B2B and B2G, I come from a geospatial background. I analyze images, and first of all, when we were taught in analyzing satellite images. For example, when you're trying to make a map, maybe a land-use map, we were able to use supervised and unsupervised learning. And so we were taught using the PCA, the K-means, and the rest of the algorithms. And so, yeah, that was back then. And so before I joined the course, I actually didn't know that. And so when we were taught these things, I was actually surprised that it's so relevant in many fields, that you're able to use the right kind of, first of all, you make the right kind of model, you know your problem. First of all, state your problem, understand your problem well, and then now be able to use the right kind of machine algorithm. And so they are relatable. They're used in both engineering fields. If you ask a mechanical engineer, he'll tell you, maybe can you try to do using this and this. They have their own maybe softwares, but they're still using the same machine algorithms.
To add to what Dennis has said, given it's B2B, I would take it from an angle of sales. And from these models, you can use them for prediction. So you could know when to order or produce some engineering products and who to sell to at what given time. Yeah, just to add on that. Thank you.
Okay, thank you. Thank you for that. Any other question, any other comment or concern? Okay, fine. So I think, Nelly, I'd like to invite you just to give us a feedback on how you found the program and how was your journey from the start to this end.
Thank you, Dennis. The journey was quite interesting. It started simple, then we started going uphill. But it was...
Where did it become an unhappy task?
You know, when you go to class and you think maybe you know stuff, and then you go and do the practicals, and then you learn more, and you discover you actually don't know anything. But what I'm so much grateful is that the trainers were really handy. They would really go out of their way, even out of class, to just help us catch up with the...
Sorry, Nelly. I hope it's not my internet. We've lost you somewhere. Hi, Nelly. Thank you. I hope it's not my internet.
I don't think it's yours. Probably it's hers.
Okay. Okay.
Yeah, we had a question from Facebook.
Okay.
Yeah. Maybe I think it was directed to the first group, but let me just read it. So one of our viewers is asking, the accuracy, was it on test or training set?
Okay, I'll push that to Dennis.
Okay.
That I see how relatable that was it to you. Yes, Dennis. When you talk about an accuracy of, you said 90.5 using logistic regression, are you referring to the training data or the test data?
Hello. Okay. Hello.
Sorry, Nelly.
I think I lost my internet midway. I'm sorry about that.
No, it's okay. It's okay. Technical issues anyway. So, yes, Dennis. Okay. I can push that to Tanvir's group. When you are working with your accuracies, so the accuracy, is it in reference to the training data or the test data? That's quite easy one to take. Okay. Okay, fine. So depending, of course, on what kind of then projects you are handling, that is more relatable, of course, to the training data. That is more relatable to the training data, because at the end of it all, as you train, you're going to perform a validation, and you would want to know then what is the accuracy level of then your model that you may have used. For example, they used SVM. The first step, of course, you take a sample, let's say 80% of the data or 70%, you then test, and then you proceed to train. Okay, so I hope that was well answered. Okay, so any other question? I think, Nelly, we might have lost you in between, but I know we got your sentiments on how the program was and how you found it to be generally. So before I hand these over to Timothy, allow me just to invite Brian Ananda, who is a senior actuarial analyst from Zamara, who I know is currently deploying a credit scoring model at work. That is at Zamara Actuaries. So Brian, you're welcome. Just to give a few sentiments on how data science is applicable to your industry. And then from there, I'll invite Tim, who will give a closing remark. Okay.
Thank you, Dennis. Hi, everyone. It's really great to join you here today. I'm fairly new, and Dennis, a friend of mine, whom we've worked with on a number of projects, invited me to just see what goes on at Predictive Analytics. And I must say, I'm really impressed by presentations I've seen so far, the various uses that data analytics can be put to. And this has been an area of interest for me over the last 1.5 years. I'm an actuarial analyst, and I've been in the insurance industry for some time. And right now, Zamara, the company I work for. Can you hear me?
Sorry, Brian.
Yeah. So I was saying Zamara, the company I work for, we decided to take another line of business, and that is data analytics. And that is why I got the interest to join and see you here. So far, as far as data analytics is concerned, we've been basically dealing with credit scoring. And that has been the main thing, but we're also looking to enter into other areas, majorly portfolio analytics. We are looking at lead generation. We are looking at pricing, both for banks and insurance companies. And an assortment of other things. We're also planning to go into the telco industry, where we are also trying to identify new opportunities. And I don't know, there's not much I can say at the moment about data analytics, but I think it's a really, really interesting field to go into. And so far, what I have seen, the different applications and basically what we can do with data is quite overwhelming. I don't know, maybe Dennis, is there any other thing you would have liked me to talk about?
No, I think that's precise, very precise, especially on the applications, which you've largely mentioned, and that's really amazing. Thank you so much, Brian. I know that was on a very short notice, but I wanted an external feel other than what we've prepared our students with and for, and what they have done. So allow me now to take this chance to first congratulate our students. That was really wonderful. You can already see the products, and so I would urge anyone to take this course anytime. And then, of course, remember that this would be the start of your journey in analytics. I know Tim will maybe mention this, that we are currently working on structuring who a data scientist is in Kenya and East Africa. So maybe upcoming would then see how we can package a good certification so that you are certified data scientist, especially through our courses. I'd like to wish you the very best to our students, and thank you so much. I hope as you go into the industry, you apply it to your different domain knowledge, you'll be able to be, it will be very practical and relatable anytime, so that you add value to what you have. It doesn't matter what tool you're using, it's about the skill, because what you've done, we've reskilled and upskilled you. So the thing is, now can you just play around with any tool to be able to add value to your organization? And like I mentioned and always mention, and I always say, that it starts with you first identifying the business strategy, because essentially you're no longer just a data scientist or a data engineer, you're a data leader. You're solving a particular problem based on the business strategy of your company. I really wish you well, and thank you so much. So at this juncture, allow me then to welcome Tim, who will give his closing remark, and of course, congratulate our students for the good job done. To you, Tim.
All right. Thank you, Dennis, and congratulations once again. I know it's been a long journey, so mine will not be to, again, repeat what we've mentioned before, but I think that for you, it's a conviction that is clear. You're already accruing dividends so far from this data science journey. Our work is to make sure that those dividends are coming in fast and furious, and also in different dimensions and spheres. So if you have not benefited yet from the investment that you've done in the data science journey, I think it's time that you need to start to critically reevaluate the approach that you're taking in the market. But then again, as we mentioned, that there is a professional benefit, first of all, to you as an individual. You're seeing that you're able to calibrate your career life into a different space. There's also a benefit for the company, organizations, or the business that you are representing, which ensures that you're able to have new business propositions that you're carrying on and having discussions with the clients. And perhaps that's an investment that you might need to look on how you are able to redeem in the near future. So I'd like to just use this as an encouragement to those of you who've joined this with the intention of wanting to join. We've had the intermediate data science, which is the third cohort. Very good number of you started off from the introduction data science, which was 3 months. Then we proceeded to the 9-month data science course. Just from the data that we have, a couple of you have been able to get promotions at work. You've been able to change jobs. You've been able to get more clarity in terms of where you need to focus into the future. And as you can see, we provided you with a lot of tools to help you with that. You have seen our jobs platform. Yeah, you've seen our events platform where you can be able to log in and just follow the different events that are going on. Our consulting wing, which we've been engaging with a couple of you on paying gigs, gigs that pay you, and then also just bring you back on board as also members of our staff, because I think we are still in a growth trajectory. we are able to absorb you back as one of our staff, just because we believe in what skills we've given you and the benefit that they can provide to the society as large. So today I just wanted to mention something that you're going to be the first to be privileged to know this. Janice had mentioned about measures that you're taking to ensure that this data science profession is a profession just like accounting, marketing, and I think it's a conversation we've been having both at government level, policy level, and also at academic level. So just yesterday we got an approval, and I'll just share with you so that you can see for yourself. This is the letter that I picked yesterday from the government that now we have a data professionalization registered. Yeah, so you can read for yourselves there. And you can see the date of 25th November 2020. So which means we are now a recognized association such as ISPAC. Yeah, we are now a recognized association such as MSK. So what this means is we'll be having standards that are going to ensure that whoever gets this opportunity, yeah, has to have run through a certain set of certifications. So one of the things that we're going to do with this body is first create membership registration, bring in members on board, ensure that we have standards which are developed that are adhering to the set threshold of skills that a data scientist needs to have. How do you go about different things like remuneration? How do you get paid as a data scientist? And also just the exams, because now we've got a lot of online courses that people are doing in data science, from Coursera to Udemy, but you don't know who or which course suits what. There are different breeds of data scientists. We have data engineers, data architects, data analysts. Where do they sit or where do they fit? Now this is the body that's going to be a custodian of all that. And at the backdrop of this, remember there's the Data Protection Act, which was signed into law by the president last year. We had last month a data commissioner already appointed. Yeah, and what's going to follow is data officers are going to be recruited, and in thousands, So you're going to be seeing a lot of job adverts requiring data protection officers to be recruited across the country. So what qualification do they need to have? Yeah, so we're just trying to help you prepare for the next wave of demand of data scientists by being the first to present some level of certification that shows the confidence you have in this subject matter. Yeah, so we've been doing some work in the background as well. So I'll be sharing with you a website that we had developed in anticipation of this. So as I said, we just picked this letter yesterday. What's going to follow is we're going to set up the secretariat. We had set up a secretariat, which was a shell. So it was me and a professor at the University of Nairobi and a legal protection officer, who means her background is law. So we are going to convene and call in a larger working committee that's going to ensure that we are bringing this to the next level. There's a website that we already had. So let me see if I can share the website. Here, you can visit and see the constitution of this body. It will be so this is the Data Professional Association.org. So it's a non-profit organization. So this has nothing to do with predictive analytics, please remember. So this belongs to the entire fraternity for data scientists. So we'll be expecting you to enroll in as members. You can see about us. You'll be able to see how to become a member. Yeah, the details are there. When you become a member, you'll be putting in your CV, and there are jobs that require you to be a member of a professional body. So now there's no excuse that my profession is not represented by a professional body. So at least you can see where to fit in. The objectives are there. you should be able to see the objectives clearly defined. Yeah, so let me just share this on the screen. Sorry, my email. That's the link. So you can peruse by yourself. We've not activated the membership payments yet, so we hope to start this officially in January. There'll be a launch event to this as well. Yeah, so I want you to really be among the first to be members of this association and participate actively, because you are technically data scientists. So by the time we finish even with the exam and give you a certification, there's some honorary membership that we'll be giving based on you know, the level of experience you have in the data science space. So I think that's some of the good news I wanted to share with you. And then besides that, you still have access to the 4IR platform that the predictive analytics team has been able to open up for you to be able to interact with. Yeah, so I think I wanted to leave it there. So there'll be room for celebration next year when the lockdown eases and the effects of meeting eases. I do promise you that we will have a good time. We'll actually meet somewhere and invite a few key industry leaders just to, you know, talk and motivate you around this subject area. And then also, yeah, it will be good to just have a cup of tea and wine and, you know, have a good time just for the efforts that you've invested in. We are still working on the criteria for the advanced data science, which certainly will be in partnership with a university in the US. So we are still working on those modalities. We are also working with universities locally. So we have like KCA University starting a master's in data science. We are already getting an approval that if you've done the predictive analytics course up to the intermediate level, you'll be getting a waiver of some, you'll be given some credits of some of the courses that you'll be doing when you go to your master's. So those are the things we're working up, looking into next year. I just to encourage you that yes, we have your intentions at the center of our heart and your interests well taken care of. Yeah, so if there are any questions, I'd like to invite them this moment so that you can have some feedback and some interaction from whoever would like to know a bit more information from what I've shared.
Any questions? I know, Charity, you're working with a legal organization. Could you be having a question on the same line?
Hi, everyone. Good evening to you. I came in a little bit late, a few minutes to 5, so I missed a lot of the presentation. I work in legal informatics, that is data analytics in the legal field. I don't really have a question per se, but I'd be interested to have conversations with anyone that would be able to know how we can work with predictive analysis in the legal field. Thank you, Dennis.
All right, so that's an invitation. It's an opportunity that you can take up. Yeah, so yeah, please. So I think, Dennis, how do you'll share her details with the class?
Yeah, most certainly. Yeah, I'll share details and then we'll see how we can progress that talk from there.
All right.
Okay, thank you.
Most welcome. Let me point out on one person here. Solomon, I know you've been doing Udemy courses, very many of them. So what's your question on being a certified data scientist?
Okay, thank you very much, Dennis, for that. My name is Solomon. I've done quite a good number of courses in Udemy and in Coursera about data science. Some of those questions which I have done, they teach very, very little things, like you have something on machine learning alone, then you have something like deep learning, then you have something like recommendation system, but then we don't know maybe what it takes to become a certified data scientist. We don't know maybe something like, have you been a data science, or rather, have you been fully equipped with all the skills and all the knowledge? Because we find that this field is actually growing, and we find that there are some of the things which keep on changing. Things like data visualization, there are more tools to do data visualization. Things like we have new libraries coming up, and then you don't know what everything that you need to do to become a data scientist. But now with this predictive analytics course, what predictive analytics is doing, we are very, very happy for that, because it will help us so that we can understand everything that we need to do to become a fully certified data scientist, and even to get that certification for data scientists, because you find that you can say that you are a data scientist, but there are some of the things which are very, very essential that you don't know. And someone can say that he is a data scientist, but he doesn't know maybe something like deep learning, something like computer vision, and they say that they are data scientists. But with this course in predictive analytics now, and even the restructuring the everything, and even the syllabus, we'll have more information, and will be fully equipped. So I don't have much to say, but thank you.
Okay, thank you so much. Okay, team, I think those are all the comments and questions that we had.
Yeah. Okay. All right. So thank you again, once again, and we wish you the very best in your data science journey. The door is still open for consultation, gigs, and even mentorship. So you're welcome back if you want to hold someone's hand in the journey that you've just gone through. Also remember that through volunteering, you're able to build a lot of competency for yourself and give back to society. Next year, we are running on a Kaggle initiative for giving back. So we'll be giving some free data science charity work that will be geared towards solving problems, in the modern contemporary world, such as agriculture, healthcare, and education sector. So be on the lookout. Let's keep engaging on WhatsApp and the other platforms that we've set up. For those of you who've been our guests, again, karibu sana. We do have these open days every now and often. So if you would like to be included in our mailing list, please just drop down your name, email, and phone number to the chat below, and then we should be able to include you in a future mailing list of events where we invite other guests to come and talk about the exploits in data science. Yeah, so enjoy your holidays. I know it's Christmas next week. Please take care, and let's continue exercising social distancing. And we look forward to see you early next year as we start a new year, a new chapter. Asanteni.
Okay, thank you so much. Allow me to hand over the program back to Mary, who started us off. Thank you so much. Bye-bye to you all.
Hi, thank you, Dennis, and everyone for making time to attend this session. We're really humbled to have you around, and we're looking forward to have you join us for our other programs. This is not the end. We still have the master classes. You can as well join the master class and become maybe a finance analyst, or maybe a banking analyst, HR analyst, and so on. And also keep on checking our website. We usually have articles every week. Be sure to be checking our blog to read our articles that are very, very informative. And also the 4IR Club, keep on checking the site to get more articles, more documents, more documentaries on the data science field. Thank you so much, and keep in touch.
Okay. Bye-bye.
Okay, so bye. Thank you.
Thank you. Bye.
Bye-bye.
Thank you. Bye.
Bye-bye.
Have a good evening. Goodbye.
You too.
Bye.
Thank you.
Thank you and bye.
Bye.
Thank you, Dennis and team. Bye.
Bye.